Foundations are, well, often out of sight and out of mind, yet they are the silent backbone of every structure, supporting everything above. Most of us rarely consider what lies beneath our feet, but it's there, quietly holding up our homes, offices, and cities. Most people assume foundations crack because concrete eventually wears out. That explanation is simple, convenient, and honestly, often incomplete. In reality, many structural failures begin long before concrete is ever poured. The real problem usually exists beneath the foundation itself, in the soil, drainage, compaction, and preparation methods hidden underground, where nobody looks once construction is finished. Ancient builders understood this with remarkable clarity. Across the Roman world, medieval Europe, the Andes, and parts of Asia, there are stone foundations that have survived earthquakes, floods, frost cycles, and centuries of environmental pressure with surprisingly little structural movement. Meanwhile, many modern foundations begin cracking within decades. The difference was not simply material quality. Ancient builders often had fewer resources, less machinery, and no industrial cement. What they possessed instead was a practical understanding of terrain and a construction philosophy built around environmental adaptation rather than short-term speed. The philosophy behind ancient groundwork was, honestly, as much about patience as it was about engineering. Builders took their time to study the land, choosing sites carefully and adapting their methods to the unique challenges of each environment. They understood, perhaps better than we do today, that a strong foundation is not just about what you build, it's about how deeply you understand the ground beneath your feet. This wisdom, passed down through generations, allowed their structures to endure for centuries, reminding us that sometimes the old ways really do stand the test of time. They treated the ground itself as part of the structure. That older mindset shaped roads, military fortifications, bridges, temples, and entire settlements. And in many cases, it produced systems that outlasted the industrial methods that replaced them. The ancient method began with preparing the earth before building anything above it. One of the greatest misconceptions about historical construction is that ancient civilizations relied mainly on massive stone blocks for durability. Archaeological evidence consistently suggests otherwise. The visible structure mattered less than the invisible groundwork beneath it. Roman engineers demonstrated this principle repeatedly. Before roads or public buildings were constructed, workers excavated unstable soil and replaced it with carefully layered gravel, crushed stone, and compacted fill. These layers dispersed weight gradually while preventing moisture from collecting beneath the structure. This really mattered because, well, water is actually one of the primary causes of foundation failure. You see, modern concrete slabs often crack when trapped moisture ends up changing the density of the surrounding soil. Clay, for example, expands during wet periods and then contracts during drought. Frost can even penetrate waterlogged ground and, as a result, lift sections unevenly upward. Over time, stress fractures just spread through these rigid concrete surfaces. Throughout history, people have learned to adapt their building techniques to the challenges presented by water and shifting ground. Instead of simply resisting nature, builders gradually developed methods that embraced resilience and flexibility. By understanding their local environment, they managed to create structures that could withstand the test of time, even as conditions changed around them. Ancient builders, approached the problem quite differently. Instead of creating completely rigid systems, they built foundations capable of draining water and tolerating gradual movement without catastrophic failure. Roman roads, for instance, survived partly because they shed water continuously through layered drainage systems. and medieval stone foundations often relied on rubble trenches that allowed moisture to escape naturally beneath structures. In earthquake-prone regions, builders developed even more flexible solutions. The Inca Empire created some of the most resilient stone foundation systems in pre-industrial history. In the Andes, earthquakes repeatedly destroyed rigid structures. In response, Incan builders refined dry stone construction techniques using tightly fitted interlocking stones without mortar. These foundations absorbed seismic movement rather than resisting it completely. During earthquakes, the stones shifted slightly, while maintaining overall structural integrity. Stress dispersed across the structure instead of concentrating inside rigid joints. Centuries later, Spanish colonial buildings constructed with more rigid masonry often suffered severe earthquake damage, while portions of older Incan stonework remained intact beneath them. Throughout history, advancements in military engineering and the introduction of modern tools have continued to shape the way we build. From ancient fortifications to contemporary seismic innovations, each era has contributed new techniques and materials, allowing structures to become even more resilient and adaptable to the forces of nature. This was not because ancient builders possessed secret technologies. It was because they understood environmental movement better than many later builders did. That understanding extended beyond monumental architecture. Military engineers throughout history treated foundation stability as a survival issue rather than a cosmetic concern. A fortress wall built on unstable ground became a liability during siege warfare. Water infiltration weakened earthworks, frost cracked defensive structures, settlement destabilized artillery positions. Roman military camps reflected this awareness clearly. Legions constructed fortified encampments rapidly, but even temporary defenses required drainage ditches, compacted roads, and stabilized foundations. Poor ground preparation created mud, disease risks, transportation delays, and weakened defensive barriers. Terrain itself could determine whether an army survived prolonged campaigns. Over the course of history, we see time and again that the challenges faced by ancient engineers echo through the centuries. The lessons learned from the past about terrain, water, and the relentless force of nature continue to shape our understanding of construction and warfare. As we reflect on these enduring patterns, it becomes clear that adapting to the environment is not just a historical necessity, but really an ongoing lesson for every generation. Centuries later, similar problems emerged during industrial warfare. During the First World War, trench systems constantly battled groundwater and structural collapse. Engineers discovered repeatedly that poorly drained terrain undermined defensive positions as effectively as enemy artillery. Trenches built in unstable soils collapsed under rainfall, slowing troop movement and weakening battlefield logistics. The environment itself became an active force in warfare. Ancient builders recognized this reality long before modern engineering terminology existed. Construction was never separate from climate, terrain, and seasonal environmental behavior. That perspective shaped how civilization selected building sites as well. Historical settlements were often positioned on elevated ground, taking advantage of natural drainage. Builders usually avoided those flood-prone lowlands unless, of course, they could undertake some pretty extensive preparation. But interestingly, modern industrial construction has frequently reversed that logic. With rapid expansion, there was this push to develop on marginal land, all because modern materials made people assume that engineering alone could, overcome any environmental limitations. Wetlands were filled and clay-heavy soils were built over in a hurry. Standardized concrete systems ended up replacing those locally adapted foundation practices. The consequences, they became visible over time. Cracking slabs, Sinking roads, retaining wall failures, and honestly, repeated infrastructure repairs just kept piling up. What ancient builders lacked in speed, they definitely made up for through preparation. One of the least discussed aspects of ancient construction was, actually, the sheer labor invested in compaction itself. See, loose soil creates future settlement problems because trapped air pockets and inconsistent density gradually shift under weight. Ancient builders, well, they understood this through experience. Laborers compacted earth manually using heavy tamping tools made from wood, stone, or iron before laying structural foundations above them. This process was physically exhausting, but it dramatically reduced long-term movement beneath structures. Modern construction still depends on the same principle, even when machinery performs most of the work. Stable foundations require properly compacted substrate beneath them. Whether preparing gravel for roads, stabilizing paver bases, or creating durable support beneath structures, the objective remains unchanged from antiquity. A modern hand compaction tool, such as the 8 by 8 inch steel tamper with 48-inch handle, heavy-duty hand compactor tool for leveling soil, gravel, sand, asphalt ground, paver, driveway, garden, yard and blacktop repair functions, according to the same mechanical logic ancient builders relied upon for centuries. The materials and manufacturing are modern, but the underlying method, compressing unstable ground into a stable, load-bearing surface before construction, would have been immediately recognizable to Roman road crews or medieval masons. Ancient durability often depended less on materials than on preparation hidden underground. This principle became especially important in regions vulnerable to environmental instability. In northern Europe, frost heave created severe problems for rigid foundations. Water trapped beneath structures froze during winter, expanded, and lifted sections unevenly upward. Medieval builders compensated by digging deep rubble trenches below frost lines, allowing drainage while distributing seasonal movement gradually across the structure. Japanese builders developed another variation in earthquake-prone regions. Traditional wooden structures frequently rested on carefully balanced stone bases rather than rigidly fixed foundations. Controlled flexibility reduced catastrophic collapse during seismic events. Modern seismic engineering eventually adopted many similar concepts through expansion joints, flexible supports, and base isolation systems. What appears modern today often reflects lessons ancient civilizations learned through long-term observation and repeated structural failure. This does not mean all ancient construction was superior to modern engineering. Industrial materials made possible enormous advances in sanitation, transportation infrastructure, urban density, and structural scale. Reinforced concrete remains one of the most useful construction materials ever developed, but historical comparison exposes an important difference in priorities. Ancient builders expected structures to endure environmental stress for generations because replacement was slow, expensive, and often dangerous. Modern systems frequently prioritize speed, efficiency, and mass development under economic pressure. As a result, ancient construction cultures paid extraordinary attention to terrain preparation, drainage behavior, and long-term settlement patterns. Those lessons are becoming, increasingly relevant again. Flooding, drought cycles, soil instability, and aging infrastructure are forcing modern engineers to reconsider many older principles once dismissed as outdated. Permeable foundation systems, layered aggregate bases, flexible structural design, and drainage-first construction are returning to prominence because environmental realities continue operating regardless of technological confidence. History, it repeatedly demonstrates that durable structures are rarely created through strength alone. They survived because their builders understood movement, moisture, terrain, and time. The ancient method was never mysterious, it was disciplined observation combined with patience and environmental awareness. Builders accepted that the earth beneath every structure was active and constantly changing. Instead of ignoring that reality, they built systems designed to cooperate with it. That is exactly why some ancient stone foundations still stand, while modern concrete continues cracking around the world. And it is why studying forgotten construction methods still matters, not simply for historians, but for anyone thinking seriously about resilience, preparedness, and the long-term survival of the systems modern societies depend upon. If you enjoyed this deeper exploration into forgotten engineering history and the hidden logic behind ancient construction, subscribe to History Vault and share this video with others interested in historical mysteries, survival knowledge, and the practical lessons civilizations leave behind.